Hello guys and welcome back. In this video we're going to look at something called the for each loop in Houdini. And I have this set of curves and I want to run an operation on these curves to convert them into spirals. So I want to take this curve and add multiple curves surrounding it, and as they progress through the curve I want them to rotate and swirl around that. And to do this, we need to operate on each curve individually. And we can do that in Houdini by using a for each loop. And what it does is it figures out based on an attribute that you provided or based on the connectivity how it's going to loop over the data. So in this case, it can figure out that you have separate curves and we can loop over each one of them at a time and process it. And we need access to this curve individually because we're going to compute and run certain operations that can only be run individually. We cannot do them all at the same time while we have all the curves included. We just need one at a time. And then we're also going to use this for each loop to run an operation specified by us on this curve multiple times. And what I want to do is I want to find an interesting vector that I can use to push these points along. So in this case we have this curve. I want to apply some kind of displacement to these points along, let's say, this vector pointing upward, and then I'm gonna use another vector pointing this way and push the points again, and then do this again with a vector pointing downward and towards the left, and then merge all that result so I have 5 or 4 different curves added, and this way I can fill in the surrounding with this curve. The displacement amount will decide how far or how big the circle of this expansion is going to be. Let's say we have a geo, for example. We're going to create a point VOP. We're going to create a facet node, and I'm going to compute the normals. So we have vectors pointing outward from each surface. I'm going to dive inside. I'm going to do a displacement to the point position. So I'm going to use an add node. Pardon me, and add the normals to the position and then plug that back in as the position. So I'm going to use a multiply by constant and reduce this amount. See, now we're pushing the geometry along that vector. So if we can do the same thing with the curve and find a normal or a direction that we can use, we can push these points along. And let me, and for that I'm going to use the polyframe and compute the tangent. And let me store the tangent into the normals so we can view it. Okay, so that's our tangent vector. You can see it's following the surface. But if let's create a point VOP, dive inside and do the same thing. Use an add node, connect P, and add n to it and push it outward. Plug it out so to override the position. You can see the result is not very interesting, and we don't need the normal or the tangent to do this because it's not pointing the right direction. What we need is we need to compute the cross product of this guy, of the tangent. Okay, so let's do this. Let's dive inside. Disconnect this, I don't need it. I'm going to compute the cross product and plug it out. And now look at that. We have a very interesting vector that we can use instead to push the curves. So let's plug this in and push the points along that vector. And let's resample, let's use an add, a multiply here, and let's add a normalize to make sure that everything is good, and let's expose this multiplier and go up. Now it's set to 0, and you can see let's template this original curve. It can push it in an interesting direction. Okay, we have the first point, it's not working correctly. We can later delete that, or maybe we'll try a different computation method of this information of the tangent. So I changed it to first edge. Let's try primitive centroid. Primitive centroid, not so interesting. Texture UV is not going to work, so we'll keep it at 2 edges, and we'll later delete the point number 0. That's all. Okay, and let's resample the curves because there's a lot of points already. So let's resample it. 0.25, and it's working. Okay, so what I want to do now is I want to rotate this vector. See this guy here? This vector, the cross product, I want to rotate this. Okay, and I want to rotate it with this point being the center, and the axis I want to use is the tangent, which is this. So for that, I'm going to use a transform matrix. I'm going to plug in the pivot, which is the point position, and the position itself is the cross product. This is the result, and let's plug this into N, and let's rotate this. And you can see we're able to rotate the curve nicely. All we have to do is we need to use a normalize node to make sure that its length is correct. Okay, very simple. And what I'm going to do is I'm going to run this operation multiple times. So let's expose this transform rotation thing. So I want to expose this controller so I can change it here at the upper level. You can see the curve is rotating, but I don't like how the rotation is working. I think there is multiple points in there, so let me just fuse them like that. Yeah, the fuse is helping. Fuse, resample. Yeah, now it's working properly. Sorry about that. So we have the curve, we have the offset working. It's unplugged right now, but you can see the rotation is also working. But if we look here, look at these guys. This is the original angle, and if I rotate this, look how it's not oriented properly. I want it to rotate nicely, and the reason for that is because this node does not take into account an axis, and to do that we need to use something different. We need to use something called quaternions. Hopefully we'll talk more about this in the upcoming weeks, but for now we're gonna use it and trust me on this. So I'm gonna create a quaternion, and what it needs is it needs a normalized rotation vector, and this rotation vector is going to be my original tangent. Okay, I'm gonna plug that in here. It gives me back a quaternion. It's a vector 4, and what I can do is I can rotate by quaternion. So Q rotate by quaternion, or Q rotate is the name of the node. And what I want to do is I want to rotate this cross product vector, or the normalized of that, with this quaternion. Let's plug that into the normal. Now we have 0. Let's change that, and look at that. It's working. Now why is it snapping like that? It's because this is in radiant. We need to convert it from, we need a degree to radiant node, so we can easily, we use a 0 to 360. Let's export that, and let's change this value to 90 degree, and now we have 90 degree rotation. See, we're doing this. Okay, cool. Let's plug this vector into the, let's normalize it first, and then use it as an offset to the point position. And then we have a multiplier, we have a rotation. Let's set this to 0, 0. This is our original curve. Let's template the original one, and I want to push it this much. So this is curve 1, and I want to push it. I want to keep the same offset, but I want to rotate it 45 degree. Okay, so this is my second one. See, this is the original curve. This is the second curve, and if I rotate, it's gonna keep rotating around it. So let's do this multiple times. 90, 180, 360 just to fill in the circle. And let's merge all of them. Okay, and now we have multiple curves surrounding the original one. And look at it, it's in the center. So 270 there. Our curve is in the center. And it's following the curves nicely. Cool. So in the next video, we're going to add a couple more features to these guys to make this more interesting. So we'll do that in the next video. Thank you guys for watching, and see you in a bit.